Welcome back to the second lesson in Unit 5. We are going to continue with the angles in standard positions. However, today we're going to look at the angles in all four quadrants. Okay, so recall in 5.1, we were just looking at the angles in the first quadrant. Now we're going to look at all four quadrants. Okay, so, well, the other three now, I guess. So recall this is quadrant 1, and then 2, 3, and 4. Okay, so that's what we'll be doing for this lesson here. So here's the kind of like a warm-up question. This question is kind of interesting because it relates slope with angles in standard position from what we did last lesson. You might think, okay, how does slope and angles in standard position relate, right? So let's take a look. It says determine the slope of the terminal arm. So if we draw the diagram, here is the terminal arm, and it says the angle in standard position is 20 degrees, so here is 20 degrees, and we're looking for the slope of this line. This is this terminal arm. We're looking for the slope. Now recall, slope is equal to rise over run. So you can see in this case, rise is simply the height of this triangle, and run is simply the x value of this triangle, right? The adjacent side. So it's just y over x. Now, if you recall, y over x is the same thing as tangent of angle. So actually, the slope for this terminal arm is simply tangent 20 degrees. And that's it. Okay, you could put that into calculator and see what you get. Sure, I'll do that. Tangent 20, this is 0.36. Okay, so that is the slope of this terminal arm. Okay, so it's kind of interesting how these two concepts are related this way. Okay, so really it's asking for tangent of 20 degrees. It's just in a very different wording. Okay, that's okay. I mean, I guess that's what makes sometimes math a little bit complicated, is you need to bring all the different aspects of math together and apply them, combine them together. Okay, anyways, so that's what we did sort of last time. We are going to be looking at new things here. This is reference angle. This is new. Okay, reference angle is basically is measured. Okay, so this is measured between x-axis and terminal arm. Okay, so last time we talked about angle in standard position. That was measured between the terminal arm and positive x-axis, always starting from positive x-axis. Reference angle does not have to start from positive x-axis. It is always, however, it is measured between x-axis and terminal arm, and it is always less than, so between, okay, let me call this theta r. Okay, I always use theta r to denote reference angle. Theta is the angle, and r to denote its reference. Okay, so it is always between 0 and 90 degrees. Okay, reference angle is always less than 90 degrees and bigger than 0. Okay, so I'll show you some examples. Okay, so let's see. First example, it says, what are the reference angles for these following angles here? So we have 145 degrees. So first of all, what you need to do is, let's draw 145 degrees. Where is 145 degrees? These angles are angles in standard position. Okay, so it's going to start from positive x-axis and rotate counterclockwise. Recall each quadrant, right, from here to here, this will be 90 degrees. So 145 is going to end up in the second quadrant, right? Because if you go full two quadrants, that will be 180. So it's not going to be full two quadrants. It's going to be a quadrant and a bit. So this is 145 degrees. Oops. The arrow should be drawn here. So here is the angle theta. Reference angle, again, it says it's measured between the x-axis and terminal arm. So x-axis is this right here, and here is the terminal arm. So really there are two options. Either this angle right here, because that's between x-axis and terminal arm, or this angle right here, because that's also between x-axis and terminal arm. Now, the key is here. It says it is always between 0 and 90 degrees. So we are actually looking at this angle right here, theta r. So reference angle is right here. Now, how do we figure out what is the measurement of this? Well, we do know if we go if we rotate counterclockwise 2 full quadrants, it's going to be 180 degrees. Now we're not rotating full 2 quadrants. We're only rotating 145. So we need to figure out what's the remaining, right? What is the remaining angle there? So if you just do 180 minus 145, that will give us 35 degrees, and this is the reference angle. This right here is 35 degrees. Okay, 210 degrees. So again, first step is to draw out the the angle. So we just mentioned if we go 2 full quadrants, that's gonna be 180. If we go 3 full quadrants, it's going to be 270. Again, that's multiple 3, right? 90 times 3, right? 210 is not quite 270, so it's going to end up somewhere in the third quadrant like this. So this is 210 degrees. Now, the reference angle, again, is between x-axis and terminal arm. So here's the x-axis, here's the terminal arm, and we know it's always between 0 and 90 degrees. So our reference angle is going to be right here. I'll use red in this case. This is the reference angle right here. This is the reference angle. Okay, and how do we figure out this reference angle? Well, this is a little bit more than 180. Well, how much more? Well, to figure that out, you go to 210 minus 180, and this tells us that we rotated 30 degrees more than 2 full quadrants. So the reference angle is 30 degrees. Okay. 300. So I think you can see what's coming. The first example was in second quadrant. Second example is the third. You probably guessed it. The last one will be in the fourth quadrant, and you're definitely right. If we rotate 1 full rotation, it's going to be 360 degrees, right? 1 full rotation is 360. 350 is not quite 360 yet, but it's definitely more than 270. So 350 degrees, 350 degrees is going to be right here. Okay, so that's 350. Again, if we're looking for reference angle, it is between the x-axis and terminal arm. So this is between x-axis and terminal arm, and it's definitely less than 90 degrees and more than 0. So that's the reference angle. And how do we find the reference angle here? Well, it's not quite 360, but it's close. So again, the question is, how much more do we need to go to rotate to get to 360? So then to do that, you go 360 minus 350, that gives you 10 degrees. So the reference angle here is 10 degrees. Okay. Finally, for 37 degrees. 37 degrees is simply in quadrant 1, so that's somewhere here. That's 37 degrees. The reference angle, again, is between x-axis and the terminal arm. So really, the reference angle is itself, because that's between x-axis and its terminal arm, and it's definitely less than 90 degrees. So the reference angle here is just 37 degrees. Okay. So that's how you find reference angle from each one of those from each of those 4 quadrants. Hopefully that makes sense to you. For the practice questions, you're doing the opposite. Okay, it says determine all the angles between 0 to 360 in standard position that have a reference angle of 25 degrees. So you should have to be honest, I don't really consider 37 degrees as its reference angle. That's just 37 degrees, right? The reference angle, there's no reference angle for 37 degrees. 37 degrees is just 37 degrees. So you should figure out 3 angles between 0 and 360 that would have the reference angle of 25. Okay, so go ahead, do that. You should have 4 answers. I'll pause the video. You should pause the video too. Okay, good luck. All right, so here will be the answers. I still show the angle in the first quadrant because, I mean, if you look at that compared to the definition, really it's 25 degrees, I guess, is a reference angle with 25 degrees, okay? But that's how you do it. If the reference angle is in the second quadrant, you go 180 minus 25. That's how you would do it in the third quadrant. You add it to 180. If it's in the fourth quadrant, then you take 25 degrees away from 360, and that would be the angle in, those are the angles in standard position, okay? All right, so hopefully that wasn't too difficult. Reference angle is very, very important, okay? You'll see reference angle, we'll use reference angle pretty much from now on till the end of the chapter, okay? So make sure you know how to figure out how reference angle works, okay? Let's look at the second example. It says the point B, 3, 4 is on the terminal arm of an angle theta in standard position. Determine the primary trig ratios of theta and the measure of theta to the nearest degree. Okay, so this is actually from what we did last lesson, okay, because 3, 4, it is somewhere here. Okay, so this is B, 3, 4. So that means the x value is 3, the length for that, the height is 4, and here's the angle theta, okay. We're looking for the primary trig ratio. So if you recall, primary trig ratios means we're looking for sine theta, cosine theta, and tangent theta. Actually, this triangle, we might have seen it in the previous lesson. Actually, this is your special triangle, right? 3, 4, 5 triangle, if you recall. Again, if you're not sure, you can always use Pythagorean theorem to figure out the hypotenuse side. So r squared is equal to 3 squared plus 4 squared. That's a squared plus b squared is equal to c squared. So r squared is equal to 9 plus 16. Add them together is 25. Solve for r by square rooting both sides. You should get r equals to 5. Again, that's the 3, 4, 5 triangle. So for sine theta, recall, is opposite over hypotenuse. So the opposite side from the angle is 4. Hypotenuse is the longest side, which is r in this case. So that's 4 over 5. Cosine is adjacent over hypotenuse. So that's 3. That's the adjacent side, so the side right next to it is 3 over hypotenuse, which is 5. Tangent is opposite over adjacent, so 4 over 3. Okay, so this is the opposite, this is the adjacent side, and this would be the hypotenuse. Okay, so these are the primary trig ratios of the angle theta, and finally we're looking for the measure of theta. So you can pick any one of these 3 ratios and take the inverse of that trig ratio to figure out your angle. Okay, so I'm just going to use the inverse sign, okay, because that's the one on the top. It doesn't really matter which one you pick. So inverse sine of 4 over 5 will give us 53, does it nearest degree? So 53 degrees. Okay, so that's how you figure out the angle. Okay, so again, this is what we did last time. Now, we are going to take this and we're going to take this information to the second example and we're going to learn something new here, okay? So it says now, take the triangle in example 2 and move it to the second quadrant. Determine the primary trig ratio of theta and the measure of theta to the nearest degree, okay? So we're going to take this triangle right here, and we're going to rotate it, move it to the second quadrant, okay? So I'll show you. It will look like this. Let me use a different color here. So again, here are our axes. It was here. Okay, I'm now going to move it over here. And this is still length of 3. This is still length of 4. And this is not the angle. Okay, the angle is not there anymore. The angle is actually right here. This is angle theta. This, you might have guessed it, is your reference angle right here. Okay, so now recall the coordinates here was 3, 4. This is no longer 3, 4. This is actually negative 3, 4. Okay, so now we can actually figure out the trig ratios now. Okay, so same thing, sine theta. We already figured out the hypotenuse is 5 from the previous example. So we can figure out sine theta, cosine theta, and tangent theta. Okay, so sine theta. Sine theta is again equal to opposite over hypotenuse. Now you might think, okay, but now here's my angle theta. I don't have a triangle here. So what am I gonna do? This is when the reference angle comes in handy, right? Here is the angle theta. There's no triangle here, but we do have a triangle right here. And we don't have angle theta inside the triangle. We have the reference angle theta. So what we're going to do is we're really going to use the reference angle and use that to help us figure out the ratios here. So sine theta is going to be opposite over hypotenuse with the reference angle. So the opposite side from the reference angle is 4 and hypotenuse side is 5. So sine theta will actually remain as 4 over 5. Okay, Cosine theta, however, is not gonna be simply 3 over 5, as you might have thought, okay? So cosine theta is still adjacent over hypotenuse, so it's gonna be 3 over 5. However, because we're in the second quadrant, notice what's happening with the x values here. These x values in the first quadrant were positive, but the x values in the second quadrant are all negatives. So cosine theta is actually, in this case, negative 3 over 5, okay? Because the angle theta is now in the second quadrant, and the x value in the second quadrant is negative. So cosine theta is actually not positive 3 over 5, but negative 3 over 5, okay? Tangent is going to be opposite over adjacent, so opposite side is right here, that's 4, no problem, and the adjacent side is now negative 3. So now you might ask, how come then sine theta we don't put negative 4 over 5, right? Because in second quadrant you can see the y value is still positive. Okay, it is still positive. You can see from the coordinates, right? The x coordinate here is negative, and well, there's my x, right? That's my adjacent side. The y value is positive, and that's why sine theta is not negative, it's actually positive 4 over 5, okay? So tangent theta is 4 over negative 3. So this is the primary trig ratio for angle theta if we move that triangle to the second quadrant. We are using the reference angle to figure out the ratios for sine theta, cosine theta, and tangent theta. Okay? All right, keep going here. And then it says we are looking for the measure of angle theta to the nearest degree. So same thing, I'm going to use this to figure out my angle theta. Now be careful, because the triangle is in the second quadrant. We used reference angle to figure out the ratios. So when you try to figure out the angle theta, you must notice, or you must figure out the reference angle first. And to do that, you simply take the inverse, again, sine, cosine, or tangent of the absolute value of the ratios. So now for sine, well, it is just 4 over 5, not a problem. Okay, so it's already positive, so it's kind of redundant to put absolute value symbol there. But let's say if you decided to use cosine, okay? If you decide to find reference angle for cosine, in that case, you would need to take the absolute value of negative 3 over 5. Okay, so in that case, it's inverse cosine of 3 over 5. Okay, so be really, really careful. Whenever you take the reference angle, you have to take, so if you're taking the inverse trig ratio, you always take the inverse of the positive ratio to find the reference angle. Okay, so we only need to pick one, we don't need to do both. So if you put this into a calculator, I think we did it earlier in the previous example here, this is 53 degrees. Again, this is the reference angle, this is not the angle theta itself, right? This 53 degrees is actually right here. This is 53 degrees. Not this, right? This clearly is more than 53. So that is angle theta. And how do we figure that out? Well, it's 180 minus 53 degrees, which will give us 127 degrees. So that's our actual angle theta. Okay, that's the angle in standard position. That's what we call the principal angle. Okay, principal angle. Okay, we're gonna move again this triangle to the third quadrant. I'll do this one. That's okay. I'll show you one more time, and I'll let you try the one in the fourth quadrant yourself. Okay. So now we're going to take this triangle and move it to the third quadrant. So you might imagine it's going to be right here. This is 3 still. This is still 4. Here is the 90 degrees. Here is the angle theta. Okay. This is angle theta. Okay. But notice how so now this coordinate is now going to be negative 3, negative 4. Okay, so this is the reference angle right there. Okay, so now same thing, we can use this triangle in the third quadrant and figure out the ratio for sine theta, cosine theta, and tangent theta. Okay, so let's see. Sine theta is opposite over hypotenuse. Oh, hypotenuse is 5. Okay. Opposite side from the angle, the reference angle is 4, and the hypotenuse is 5. Now notice we are in the third quadrant now. What are the y values for sine? what are the y values for any points in the third quadrant? You can see this is the opposite side, right? So we're looking at the y values in the third quadrant, and all the y values in the third quadrant would be negative. So sine theta is actually negative 4/5. Cosine theta is adjacent over hypotenuse. So adjacent is the x value, right? This is the adjacent side, so that's the x value. Now the x value in the third quadrant is always negative. So this is negative 3/5. Tangent theta is opposite over adjacent, so that was y/x. If you recall from the previous lesson, tangent theta is y/x, which in this case is going to be negative 4 divided by negative 3. Again, they are negative because all the x and y values in the third quadrant are all negative. Now, because both are negative, so then this actually turned out to be positive 4/3. Okay, so these would be the primary trig ratios for the angle theta, in this case, in the third quadrant. Okay, now we can find the reference angle. Again, reference angle first. Now, when we try to figure out the reference angle, again, I'm using sine. This time, sine theta is negative 4/5. Recall, again, whenever you're looking for reference angle, you always take the positive ratio. So you take the inverse sine of positive 4/5. This time, same thing, you are going to end up with 53 degrees. So this is the reference angle, okay? However, if you're looking for angle theta, it's not 53. In this case, because angle is in the third quadrant, the angle itself, the principal angle, is going to be 180 plus 53. Which is going to give us 233 degrees. Okay? Again, because this is the reference angle, so it's this portion plus the first two quadrants. That's why you add it to 180 degrees. All right, I'm going to let you try the one in the fourth quadrant, and I'll show the answer in a bit. Okay, so hopefully this is what you get. Here's the diagram. The coordinates here would now be 3, negative 4. So in the fourth quadrant, all the x values are positive and all the y values are negative. Hence, for my sine theta, my ratio is negative. My ratio for cosine is positive. Again, you need to think. So hopefully you kind of see this now. Okay, so sine, this relates to y. Okay, so keep that in mind. And cosine relates to x. Okay, so fourth quadrant, all x values are positive, therefore the ratio for cosine is positive. The ratio for sine would be negative in the fourth quadrant because all the y values are negative in the fourth quadrant. And tangent, as I show you here, tangent is the combination of y and x. So tangent in the fourth quadrant here will be negative because x is positive and y is negative. Find the reference angle again. When you find the reference angle, you take the inverse trig ratio of the positive ratio. You get the reference angle in the fourth quadrant. To find the principal angle, you need to go 360 minus your reference angle, which is 307 here. Okay, so let's summarize this here. It says, in general, the ratio for cosine is positive in quadrant 1 and quadrant 4 because all the x values are positive in quadrant 1 and 4, and cosine is related to x. Sine is related to y, so sine is positive in quadrant 1 and quadrant 2, right? Because all the y values are positive in quadrant 1 and quadrant 2. Tangent is positive in quadrant 1 and quadrant 3 because tangent is the ratio between x and y, and both x and y are positive in quadrant 1, therefore the quotient will be positive, and x and y are both negative in quadrant 3, therefore when you divide two negatives, it becomes a positive number, and that's why tangent is positive in quadrant 3. So notice how every one of them is positive in quadrant 1. However, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4, and no other trig ratios is positive in quadrant 4. So we actually have this rule. It's called all student Okay, I'm just gonna write down A. All students take calculus. Okay, so A stands for all. It means all the trig ratios are positive in quadrant 1. S stands for sine. Only sine is positive in quadrant 2. You can see only sine is positive in quadrant 2. T stands for tangent. Only tangent is positive in quadrant 3. C is stands for cosine. Only cosine is positive in quadrant 4. You can see, right? But everything 1, 1, 1. Everything is positive in quadrant 1. But for 2, only sine is positive. For 3, only tangent. And for 4, only cosine is positive. So this is the all student takes calculus rule. Or there's a lot of names for this. Also the CAST, C-A-S-T, CAST rule. Or add sugar to coffee. Whatever, okay? However you can remember it. But that's the rule you need to keep in mind, okay? Very, very important. Very, very important. All right, we will do another example here. It says to the nearest degree, which values of theta satisfy the equation cosine theta equals to -1/3 for angle between 0 and 360. Okay, so now we can do this. First, it says cosine theta is equal to -1/3. So to find angle theta, you must find the reference angle first. So to find the reference angle, recall we simply take the trig ratio of the positive ratio. So it was -1/3. You need to take the positive of that. Just absolute value of the ratio. So positive 1/3. So now we put this into calculator. I have no idea what this is. And this apparent, we will round to the nearest degree. So this is actually 70.5. So if we round to the nearest degree, it will be 71 degrees. Okay, so the reference angle is 71 degrees. Now, it says cosine is negative. It actually means we have two possibilities, right? We have two cases. Case 1, cosine is negative in second quadrant. Right? And it says the reference angle, we found that the reference angle is 71. So our first angle theta 1, is actually 180 minus 71 degrees, which is 109. Okay, so that's case number 1. Cosine is also negative in the third quadrant. Now, you might ask, how do I know? Again, you need to think about cosine is related to x value. So x is negative in the second quadrant. X is also negative in the third quadrant. Okay, that's why I drew my angles in the second quadrant and the third quadrant respectively. Okay, so here is my theta number 2. Okay, so again, x is negative in quadrant 2 and quadrant 3. That's why I drew my terminal arms there. So in this case, the angle would be 180 plus 71. And this is going to be 251 degrees. So these are my two possible answers. Okay? All right. This might be a lot to take in. So there's actually a second part of this section. So I'm going to stop right here for now. You should try to practice questions first. Once you feel comfortable with this, then you can move on to the second part of this lesson. Very important, okay? If you can't get this right, the rest of this unit is going to be challenging, okay? And same as pre-cal 12. We're not quite there yet, but focus on the present, okay? Make sure you understand this, okay? All right, try some practice questions and let me know if you need help. Good luck.